In V2.8, you're asked to use your calculator to prepare a screen plot of the data. So what I've done here, menu, statistics, run the numbers, regression, and linear regression. I will copy the formula. And I get the following equation, a correlation coefficient of 0.9840. Now, resizing this, you can see there the data. Now, in order to transfer that and make a freehand copy, it's more of a sketch scenario. If this comes up in a test or an assignment, you'll either be given a bit of a grid or perhaps just a simple X and Y axis. So I can write something along the following lines for B. R is equal to 0.9840, and that's a strong positive correlation between the variables. So the larger the house, the higher the selling price. Now, going back to the calculator, just quickly running the analysis again. Regression, linear regression. So A is equal to 1.26 to 2 decimal places, and B 86.66. So writing that down. Now, the coefficient of determination in this instance, R squared from the calculator, is 96.82%. So 96.82% of variation in price can be associated in the area. Now the gradient of 1.26 means that there's a 1260 price increase for each extra square metre. The y-intercept indicates $84,660, and that would be for the land only, in other words, with no house on it. The data isn't perfectly linear because there could be other factors, such as the suburb, location, things like access to schools, transport, etc. Other factors that could be rural or urban that may have attributing things to the price. In G, substituting that figure in, using the equation to predict the selling price of a home of area 220 metres squared, we end up with 361,860. Referring back to the original data, that figure of prediction is within the given data set, so it would involve interpolation. In the case of H, predicting selling price of a home of area 350 metres squared. Now, that would seem to go beyond the given data, so this would be involving extrapolation. But we end up with a prediction of 361,860. The floor area for a $300,000 sold house, doing the substitution 170.9 metres squared. Now, in these instances, we would consider both G and L reliable because the predictions come from within the given data. They both involve interpolation from within a well-modelled equation within the data points. So both predictions made using interpolation within the given data, so hence we consider them reliable. Now, in the case of H, we've got an unreliable prediction there because we don't have within our given data the 350 metres squared prediction. So we'll record something along the following lines. So it extrapolates beyond the given data. Any extrapolation prediction is unreliable, even if it's just a very, very small advance on the independent or the dependent variable.